Today's notes are on polynomial graphs, but before we get to our notes, I want to share a joke with you. This one starts with a little girl who was talking to her teacher about whales. The teacher said it was physically impossible for a whale to swallow a human because even though a whale is very large, its throat is very small. The little girl stated that Jonah was swallowed by a whale. The teacher reiterated that a whale could not swallow a human. It was impossible. The little girl said, "When I get to heaven, I will ask Jonah." The teacher asked, "What if Jonah went to hell?" The little girl replied, "Then you ask him." Burn. Okay, moving on to our polynomial graphs. These graphs, we're going to talk about quadratic functions and also our cubic functions, something that we haven't talked too much about. And then we'll talk about increasing, decreasing intervals, some end behavior. So just a little bit of everything on this one. So for our first one, our warm-up, what I want us to do is start with this graph on a graphing calculator. So here is number one. And so just very quickly, if you take a look at it, you see the table and you see the vertex. The vertex, looking at the table, is going to be 3, -4. And so that correlates with the graph when you take a look at that. For this one, we're going to just take the table data and copy it into our notes. So right into our notes, I'm going to make the table X, Y, and what we saw was 0, 5, 1, 0, 2, -3, 3, -4, 4, -3, 5, 0, and it was 6, 5. And so we're going to sketch the graph that we have been doing in class. So I'm going to start with 3, -4. Here we go. Slightly off. Oops. There we go. And then label your points. So this is 3, -4, our vertex. My 0 is 1, 0, and 5, 0. So again, just sketching the graph. We can plot more points on here if need be. So we're at 5, 0, 1, 2, 3, 4, 5, and 6, 5. There we go. So just again sketching the graph, and then let's use this information. So have this on your paper as we answer A, B, and C here. So on what intervals of the domain is the function depicted by the graph increasing? So we're just focusing on where it is increasing. And we're talking about domain. Domain, remember, is all of your x values. And so it begins to increase at our axis of symmetry. So if you remember, our axis of symmetry is 3. So we have 3 is less than x, which is less than infinity. The other way that you can write it, it's been a while since we've seen this notation, but this is the other notation that you may be seeing this. The next one is, where is the domain? Where are all your x's decreasing? So now we're going to talk about decreasing. So all of my values of my x's, it starts at -infinity, less than x, less than 3, all the way to my vertex. This is, again, where it's decreasing. The other way that we can write it, -infinity to 3. The last thing that I want to talk about is our last notes we were talking about quadratic transformations, and I mentioned how right here, this is vertex form. And so the reason that it's called the vertex form is that you could pull the vertex straight from that information or straight from this equation. Here it is, your HK. So the vertex is 3, -4. Again, when you take a look at your equation. Also remember that when we talk about H, it's always the opposite. So even though it has a -3, we're going to take the positive, and then K is -4. So we can go ahead and find the vertex from the vertex form of a quadratic function. Moving on to number 2. for number 2, what we're going to do is we're going to, again, identify zeros, the vertex, and we're going to sketch a graph. What I like about this is, again, we can go ahead and it's given to us in vertex form, so we can quickly write down the vertex. My h is 3, so we're going to take the opposite, so it's actually -3, comma 8 for my k. The next thing we are going to do is find the zeros. And to start finding the zeros, what we have to do is we have to simplify this function. So that's my vertex, my zeros. Zeros equal to -2 x plus 3 quantity squared. Again, we had practice from this with our previous information. Over here, x plus 3 quantity squared, remember this is your perfect square trinomial. We get x squared, 3 times 2 is 6x, 3 squared is 9, plus 8. To keep solving for this, I'm going to go ahead and use completing the square to go ahead and do that. Now, before I get to completing the square, I'm going to move my 8 to the other side. So I'm going to subtract 8 from both sides. And I'm going to go ahead and rewrite this as x squared plus 6x plus 9. And I have this 2 out front. And to get rid of this 2, I'm going to divide it on both sides. When I do that, I get 4 is equal to now x squared plus 6x plus 9. I can rewrite this as a binomial squared, and then we can find the square root. I feel like I may have made a mistake in my math because it's very different than what I'm seeing with my answer key. And it is. So I apologize. I see where I made my mistake. So erase, pause if you need to. What I'm going to go ahead and do is distribute this -2. -2x squared minus 12x minus 18 plus 8. I'm going to simplify, combine like terms, and at this point I'm going to go ahead and start factoring. And so I'm going to factor out a 2, actually a -2. So I have x squared plus 6x plus 5. And then I'm going to take that and factor that. So I have factors of 5 that add to 6 is going to be x plus 5, x plus 1. We're going to set everything equal to 0. So that's not equal to 0. So I have x equals -5, x equals -1. So I get -5, 0, -1, 0 as my 2 zeros. So again, just go ahead and sketch the graph with this information. We're going to start with -3, 8, -1, 0, and -5, 0. Also, label your ordered pairs. So it was -1, 0, -5, 0, and -3, 8. Now let's move on to A, B, and C. So for A, what intervals of the domain is the function of this increasing? So we're talking about as your x values are increasing. So my x values increase from -infinity to -3. Again, I'm going to have you write it in the other form since it's been a while. When is it decreasing? Well, it's going to begin decreasing at -3 all the way to infinity. The last thing that I want to talk to you guys about is this end behavior. For the end behavior, I want you to notice that this function has an even exponent. So the end arrows, so the arrows end the same. So they end both facing up or both facing down. So again, this was arrows end the same. And what I mean by that is both up or both down. Okay, so pause if you need to. I'm going to move on. The next one, what we have here, is we are going to sketch a quadratic functions with zeros of 2 and -4, a minimum of -1, -3 over the domain of -infinity to 2. So my 0 is at 2, so I'm going to go ahead and mark that as 2, 0, and then it was -4, 0. With a minimum, so that's your vertex of -1, 3. And so again, remember that a minimum makes that type of parabola. The other thing again, pay attention to domain. Right here I have a closed circle and it does not go beyond 2, 0. So here is what I have. Okay. So there you have number 3. Number four is a cubic function. So here we have cubic functions with now 3 zeros. So cubic, you have x to the third. We have 3 solutions. A relative minimum. Okay, so another minimum. So this is kind of what it's looking like. A y-intercept of 3 and a relative maximum. So yes, it's going to go in 2 directions here. So let's go ahead. We're going to start with our zeros. So I have -5, 0, -2, 0, and 5. I have a minimum of -3.5 and -1.5. So smartboard's off, so that big blue dot right there. And so what that tells me, since that's my minimum, I have something like this going on right over here. A y-intercept of 3. So it is going to go up, and then it's going to start going down to that, it's going to keep going up to a maximum of 2, 5, right here. Oops. I see that I'm slightly off. And then back down. So there you see the minimum and the maximum. And so the end behavior here, what I want to point out, we're talking about a cubic function. This is an odd exponent. Arrows end opposite. So what I mean by that, one arrow is up, the other is down. So you can use this as an example of that. So we have a couple more examples of cubic functions. And so, and we can talk about that end behavior. So for number 5, this time I don't give you the zeros. And you're going to have to find the zeros yourself. So with our function, we are going to factor it like we would normally factor, where my GCF is x. I'm going to factor out an x, so I have x squared plus 6x plus 5. And from here, I have x plus 5, x plus 1 is my factors. And I'm going to set everything equal to 0. So x is equal to 0. All my other factors are equal to 0 as well. And so I have x equals 0 as 1, x equals -5 as another 0, and x equals -1 as my third 0. So it's cubic, so we have 3 solutions. Now, the other thing that I want to point out is the y-intercept. Since this one does not have a vertex form that we are going to be talking about, we're going to go ahead and use the y-intercept. This is something I think fairly easy to find to help us graph our cubic function. Remember, for y-intercept, we're solving for y when all of our x values are 0. And so y is equal to 0. The ordered pair is 0, 0. So let's go ahead and plot these points. I'm going to start with -1, 0, 0, and -5. Okay, and what we have going on here is it's going to look like something similar to this. And we'll talk about this some more in class on how you know which direction your arrows are going to start and begin. So we're going to use number 5 and number 6 to help us compare and come up with that. So with number 6, same thing as we're going to go ahead and start with our zeros, but I do want to point out something that we're going to compare. Take a look at that on ax squared, or I'm sorry, in this case, ax cubed. So when we factor this function, we're going to look for our GCF first. The GCF looks like it's going to be -2x this time. I think factoring out that negative will definitely help. So we are left with a positive x squared minus 2x minus 15. And then we're going to keep factoring. So factors of 15 that add to 2, it looks like it's going to be -5 and a positive 3. Set each factor equal to 0. If x equals 0, x equals 5, and x equals -3. And then the last thing we're going to do is the y-intercept, so that gives us another point to plot. And again, very easy to calculate. So if I find my y, I'm going to substitute 0 in. And so y is equal to 0, the y-intercept is 0, 0. Plotting your points, so I'm going to go ahead and start with 0, 0, -3, 0, and 5, 0. And so this time, since I have a negative coefficient first, we are going to get something very similar to this. Okay, and again, we'll talk about this some more in class. That's it. Bye now.